So in this problem we have example, what is this? Example 212. 2-12. And so what we have here, we have a 24 volt source. So I took units out right now just so we can kind of get the numbers through. I presume you know by now this is a voltage source, this is a resistor, these are resistors. There's no prefixes to anything, they're just normal resistances. So with that being said, we're trying to find V2, I1, I2, I3. So let's just go through to make sure we understand what we all have. So here's V2, okay, so it's at that point. And then what else does it say? I1, we have I1 here, cool. I2 going down, cool. I3 going down. All right, so we can start to solve this one. So I'm going to solve through this. You can try to follow along, see what parts are confusing, but this is going to be a great example of equivalent circuits and use of equivalent circuits to solve problems a little faster and a little more easily. So first thing that we do, this came from a previous lecture, but first we draw a ground node. I'm going to draw my ground node. It can be anywhere on the ground plane. So remember, all of this is a 0 voltage. All of the voltage has been used by the time it's come here. So for clarity, usually you'll draw it down here. Sometimes you can draw it over here if you want to draw it right off of this one. It doesn't matter where it is. I'm going to draw it here. That's a little bad. Let's make big and then big. All right, so that's generally the symbol for a ground node. And so, what else do we have? Actually, I think that's about it. I think we can solve. All right, so first thing that we do for this is to draw the equivalent circuit. So remember, we're trying to simplify this out. The more we simplify this circuit out, the more we can find things about it. So first off, how do we find what the current is coming out of the voltage source? So I1, which is this one, and remember, if we can just pull it because it's on the same line here, there's no branches or anything, that's the same current that's coming out of this source. So how do we find I1? Well, we know the equation V equals IR, and this can be V total equals I total, R total, or equivalent, or whatnot. So we know if we have the total resistance of all of these, we can plug it in here, and we already know 24 is the total volt, so it's going to be 24 divided by whatever this total resistance equals IT, or as we've called it up here, I1. It's the same thing coming out. So first we have to find the resistance for this part of the equation, or this part of the circuit. So the way I do that now is I look, what can I simplify? What's the easiest to simplify? And the first thing I see actually is this on the side. That's going to get added together because 2 in series get added together. And then the next thing I'm going to see is these two are also going to get added together. The reciprocals of them because they're in parallel. So we're going to start to simplify this out. So the first thing I'm going to do is I'm going to redraw this circuit a little bit. We got 24. Now we've got a resistance here. We've got a resistance here. Because remember, these two are going to simplify into one equivalent resistance. And then these two are going to simplify into one equivalent resistance. So let's just do the numbers of that real fast. So 2 plus 3, so this resistor is going to be 2 plus 4 because those just came right next to each other. So they're in series, we add them up. And then these two are going to be the reciprocal. So what's the reciprocal of this again? We're going to do 1 over 6 plus 1 over 6 up to the minus 1 equals, and that's going to simplify out to 3. So this one is going to be 3 ohms from here. And then what else do we have? We still have this 10 ohm up here. So already you can see we've simplified it down from how many is this? 2, 4, 5 to 3 resistors. And then if we look again, what do we have? So these two are in parallel and this one is in series with both of these. So why can't we go right down here and say, hey, this one is in series? Well, it is in series, but this one also has something first. So think of order of operations. Like if you have parentheses around it, you need to do that part first. And there's imaginary parentheses. You have to add these parallel up before you can get the series. So let's do that real fast. So we're going to draw another one here. 24, this one's going to come out again, still with 10. And then these two are in parallel, so we can draw them. They're going to be simplified into an equivalent resistance. And that equivalent resistance is going to be what? We've got clear. We've got, oh, I'm going to turn the light on. That should be useful. There we go. Look at that. Much better. We've got 1, and that's 6. So 1 over 6 plus 1 over 3. Cool. And then up minus 1, 2. So this is going to be 2 ohms for that. And now we can see the total resistance here is going to be simplified even one more, which we don't necessarily have to do, but we can. We're going to do a positive negative 24 coming out 12. And that 12 is our total resistance of this system. So if you look, if I just took 2 points up here from here, let's just say I made that as the point V1 here, and this, whatever happens over in this half, this whole box is being simplified into this one resistor, because essentially this is the same test point. So if we hide, let's see if we got a piece of paper. If we hide that half and we're saying what's happening over there, it's the same as saying this half right here equals that whole chunk. So we've simplified it. So what is that useful for? Well, now we can get our equation. So we have, again, up here V equals IR. I'm just going to write it down over here. V source equals I1, because remember I1's coming out over here, so we're going to put I1 times, and what is this? R equivalent, because it's the equivalent resistance of this entire system. So Vs equals I1, so we're going to substitute numbers in now. Our voltage source is 24 equals I1. We're trying to find our equivalent resistance is equal to 12, so I1 equals 2 amps. See how we got that? Divide out, I1 equals 2 amps. Cool. So we have the first bit. We have I1 up here. We already solved that. We're going to box this up, so we already have it nice and neat. Answer number 1. So now we're going to go back. What's the next step it's asking for? It's asking for V2. So V2 is right here. So it's saying what is the voltage with this spot respect to any place on this ground line. It doesn't matter where, because it's all 0 here. So what we're going to do now is we're going to do our V2 equation to be able to solve for that. So how and what are we doing for this? Well, we know that we have an equivalent circuit, and we know Kirchhoff's voltage law. Remember, that's the loop one. So we have a KVL. I'm going to do this up here. KVL, and KVL, we're just going to go down to this one. It doesn't matter which we pick. We can go up here, but we have 24 minus 24 because we go through that voltage source, plus IR. So we have our R is 10 ohms, and then our I is I1, which we've solved down here, which is 2. So 2, and then we are going to let that be because we're trying to find the volt at this point. So if you continue through this section or continue through this part, that's going to bring you back to 0. We don't want 0 right now. So that's going to equal our answer, actually. So we got minus 24 plus 10, so that's going to be 10, 4 equals about 4 amps. And why is this a positive versus a negative? So what I did here is essentially I simplified Kirchhoff's voltage law to be able to find out that this is for volts, not amps. Wow, guys, that was bad. Okay, so that's an easy way to find it. Let's see if there's another way to do this. I think that's pretty much it for that one. You could also just take V equals IR and do it that way and find the voltage drop over that. Essentially, that's what we're doing here. So 4 volts equals V2. So that's saying of the 24 volts, 20 of them went through this resistor. Because remember, 2 times 10 equals 20. So 20 volt drop over this resistor from here to here. And we have a total of 24. So 24 minus that drop equals 4. And that's how we're going to do that. So that's going to be the first one. And then we're going to grab a second one here for I1 we already solved, so that one's done, that one's done. I2, where is I2? So I2 is right here. I2 is going to be a little bit more fun to solve. So we can use Kirchhoff's current law to be able to do I1 equals I2 plus I3, but we don't have I2 or 3. So let's figure out another way to do this. We've got, however, V equals IR again as a primary equation, and we know what the voltage at V2 is. So voltage from here to here, going through both of these resistors, that voltage is going to be 24 minus 20 equals, again, 4 volts. So 4 equals, and then I is the I2, which we're trying to find. And then R is the equivalent resistance of these, which we simplified it down here as 3. And so 4 over 3 equals I2. Cool. So we've solved I2 there. And now we're going to have I3. So let's go for I3. Okay, multiple ways to solve this. I like Kirchhoff's current law here. So we have I1 equals I2 plus I3. Let me move that away. And so we already have 2 equals I2, which is 4/3, plus I3. So 2 minus 4/3 equals I3. 2 minus 4/3 equals what? 4/6 equals I3. So that should be a pretty good set of each of these variables. Let's make sure we got everything through. Yes, 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 yes. Good. So that's essentially how we solve these.